Hi everyone, my name is Derek Chang, and today I'll be solving section 3.2.5, problem number 8 of the textbook for video problem number 5. So the image shows us a small section of graphite, which is a material entirely made of carbon atoms, and these atoms are arranged in repeating hexagons like a honeycomb. In math and science, we often describe positions using x and y coordinates like a grid, but that does not work here because the honeycomb pattern is tilted. So instead, we use a different coordinate system based on the two directions that follow the edges of the hexagons. These directions are called vectors, and we label them v1 and v2. Our goal is to use steps in v1 and v2 to describe where each carbon atom is, and so on. So for part A, in this new coordinate system, each carbon atom's position is described by how many steps we take in the v1 and v2 directions. Starting from the atom labeled 0 on the bottom left, if we look for 1, 0, we are simply looking for one step along v1 and 0 along v2, and that lands us on the yellow atom to the right of 0. When we are asked to look for 0, 1, that is 0 along v1 and one step along v2, and that reaches the yellow atom above and to the left of 0. And finally, when we look for 2, 1, that simply says that we're going 2 steps to the right along v1 and 1 step up along v2, and that lands us to the middle right atom of the yellow hexagon. Now let's find the 6 atoms that form the corners of the yellow hexagon. Starting from the atom labeled the origin at 0, at the lower right it is 1, 0, the right is 2, 1, the left is 0, 1, the upper right is 2, 2, and the upper left is 1, 2. Now for part C, we are asked what are the coordinates of xb of the center of that hexagon, which is labeled C. So visually, what we can see is that a linear combination of v1 and v2 should bring us to the center, which is labeled C. So xcb would simply be 1, 1. And for part D, we are asked, how do the coordinates of the atom in the hexagon whose lower left corner is labeled 1 compare to the coordinates of the hexagon whose lower left corner is labeled 0? So for this, what it's simply asking is, looking at the image right there, is how can I transform the points from the yellow hexagon to the gray hexagon whose point starts with 1? And what I found is that if you add 4, 2 to every atom, it will simply transform the vector that starts on the yellow hexagon and go to the gray hexagon. So simply adding 4, 2 to every point will allow us to achieve this. So after that, we get 4, 2, 5, 2, 5, 3, 4, 3, 3, 3, and 3, 2. And finally, for part E, we are asked, does the point X, whose coordinates are xb, 16, 4, correspond to a carbon atom or a center of a hexagon? And what I found actually is that this should be the center of a hexagon. And the reason I think this is true is if we were to simplify this vector into a shorter form, we would get 4, 1, b. And going back to one of our diagrams, if we were to actually map that out, this would be 2, 3, and 4 would be here. Or sorry, here. And then the 1 would bring us here. So if that's what the scalar for that is implied, then it can only be assumed that 16, 4 would be the center of a hexagon. Thank you very much. I hope this explanation was helpful. Have a great day.